we're going to start talking about some composite figures. We have some more like application-y type problems, so I really enjoy this. Today, we're going to be talking about shaded area. And we're going to look at two different methods to find the shaded area of a composite figure. In the first one, which I think is probably a little bit easier, I think of this as like a building block method. We're going to figure out all the individual shapes in a diagram, and we're going to kind of just add them together, like how you put a bunch of different shaped building blocks together to make one full shape. So in this first one, they love these kinds of problems because they are symmetrical. So these like sports courts or whatever, they are symmetrical, so we can keep that in mind. The first thing that I want to do is figure out what kinds of little shapes do I see in here. So just like look at those shaded regions. It's like the keys of the basketball court and the big center circle in the basketball court. What shapes, what like basic shapes do we see in here? I know you guys recognize shapes. So what shapes do you see? Caitlin? How many full circles do you see? I see one in the center. What about on the sides? Do we see those semicircles that are formed over here? Yes? If I have two semicircles, how many full circles does that make? One full circle, right? So I have a big full circle in the center, and I have two full circles on the, I have one full circle on the outside, split in half. So that would make this the area of two circles. This is my first building block. Plus, what other shape do I see in here? I got the circles. I also see what? Oops, I wanted a different color. There we go. What's the other shape in there? Oh my gosh, you guys. This is it's not a square, it's a rectangle. All right, so I also see the area of two rectangles. So now I'm going to write out my formulas for each of these things. Two circles means I want 2 times the area of a circle, which on your little sheet is pi r squared. So pi, the radius of one of these circles is going to be half of its diameter. So the diameter is 12, the radius is 6. So 2 times pi times 6 squared. Plus the area of two of those rectangles, they're symmetrical, so they should be the same. 2 times base times height. Just like that. And I'm purposely leaving it like this all in one big line because I'm going to go to my, I'm going to go to my calculator and I'm going to type this in. So in my calculator, I am literally typing 2 pi radius 6 squared plus 2 times 19 times 12. And I'm going to get 682.2. This is as exact as I want it. You should be exact to one decimal place if possible. So 682.2. Are you really cool with that? Building blocks, we're adding them together. Let's do another one. Pretty much exactly the same. This is a weird shaped pool. If your pool looks like this, I'm sorry, but it's weird. The dimensions of an irregularly shaped pool are shown. What's the surface area of the pool? Okay, here we go. What shapes do we see? Just like basic elementary school shapes. Caitlin. I see one triangle. Let's start there. Area of this triangle. It's not an equilateral triangle, so I can't use 1/2 apothem times perimeter. I got to use my regular triangle formula, 1/2 base times height. The base here, I think, is 32, and the height here is 15. So I'm going to do 1/2. Oops, I don't want this equal sign in here. 1/2 base times height. 32 times 15. Perfect. That covers the triangle. What other shapes do we see, Anna? A rectangle in the middle here. So that rectangle is going to be base times height, 32 times 16. And then on the sides, I see what? Yeah. I see one full circle, right? Two semicircles make one full circle. So I'm going to call this just the area of a circle, which is pi. Radius is half of my diameter, so that's 8. Pi 8 squared. Beautiful. Can we take that whole thing and put it into our calculators now? 1/2, 32 times 15. Oh gosh, I'm not going to remember all these numbers. 1/2, 32 times 15, plus the area of my rectangle, 32 times 16, if I can type, plus the area of that circle, pi, radius is 8 squared. I got 953.1 feet squared. Everybody cool with that? Okay, flip it over. For number 3, I still want to use this building block method. What shapes do we see, Caitlin? How many full circles do you see? 2 full circles. So the area of my shaded region is going to be 2 circles, which is 2 times pi r squared. Yes? Now I need to do a little bit of extra work in this problem because I don't know the radius of one of these circles. So let's zoom in here. I know that my building blocks that make up this shape are semicircles, but what is that shape that it's forming in the center of my building blocks? What's this shape right here? If you had to guess. Anna? It's a square. So we're going to figure out, using that square properties, we're going to figure out what the radius of one of those circles is. So I'm going to, let's highlight this radius right here. That's the radius I'm deciding we're going to find. Now I'm going to connect up that line that it's giving me to that radius. Guess what that's called? The apothem. And then using my square properties, do we remember what kind of triangle is in there? Should be a 45, 45, 90 triangle. If the hypotenuse of a 45, 45, 90 triangle is 6, then one of its bases, which is the one that we're trying to find down here, is going to be 6 divided by radical 2, which simplifies to 3 radical 2. Good? That's now the radius of one of those circles, which is the part that I needed to fill in this equation. So let's fill it in. 2 pi radius 3 radical 2 squared. Now, if you're careful, you can plug this right into your calculator. Your calculator, depending on what kind you have, will probably put an extra set of parentheses around that 2. So just be careful that you're typing it in carefully. But if you want to simplify this by hand, the one thing that I need us to remember is that when I square this 3 radical 2, it's actually like 3 squared and then the radical 2 squared. Both things become squared. Yes? So when I simplify, 2 pi times 18 is 36 pi. I like exact answers, so if you want to leave it as 36 pi, I'll take it. Otherwise, this ends up going to be 113.1 centimeters squared. Okay, good. Any questions on this? Making sense? We're adding all of our pieces together. Okay, the second method that we're going to talk about, I refer to as like the hole puncher method. This one's a little bit different. Instead of adding building blocks together, we're going to take a look at like one full-sized, I think of them as like pieces of paper, and we're going to hole punch out the shapes that we don't want. So in number 4, this one's pretty nice because it's like actually paper shaped. You're imagining that whole silhouette as a piece of paper, and then you're cutting out of that paper 2 circles. So instead of adding pieces together, we're going to subtract pieces away. So I like to kind of start by writing this out. The area of my shaded region is going to be equal to the area of the whole thing minus the area of the hole punch. Maybe that doesn't make sense because they're both whole, but you get the idea. So the whole shape, I have to take a look at what is the silhouette. I don't care what shapes it makes in the center. I'm going to look at this outermost shape. What shape is that? Should be a rectangle, right? So the area of this whole shape is the area of a rectangle. And then I'm going to need to subtract away the area of two of those hole punches, two circles. Cool? Yes, we see the idea, the plan. Okay, now let's execute that plan. The area of my rectangle is base times height. The base of this rectangle is 10. How am I going to figure out the height of this rectangle? It's not given to me, so I need to do some extra steps here. Any ideas? Maybe tricky. Okay, we're going to kind of imagine that these circles, they don't really look like it, but we're imagining that these circles are the same. They're touching all the sides of the box. They're exactly equal, which means if the length of that box is 10, then each one of these circles must be 5. 5 and 5. That part of the circle is called the diameter, right? So if I have a diameter of a circle going side to side, does the diameter change at all when I draw the diameter going vertically? Should be the same diameter. So if it was 5 going side to side, it's going to be 5 going up and down. It's a really good problem. There's one like this in your homework, so make sure you understand what I'm saying here. So that whole rectangle is a 10 by 5 rectangle. Good? Now let's do the hole punch. We are hole punching out 2 circles. So minus 2 times pi. The radius of one of those circles is going to be half of the diameter. So that's like 2.5 squared. 2.5 squared, I think it's like 6.25 or 6.75. We're going to multiply that by 2 to get 12.5. You can put this all in your calculator too. I just like simplifying a little bit. So in my calculator, I'm typing 50 minus 12.5 pi to get me to 10.7 feet squared. If you get a negative number, you did something wrong. Either your hole punch was bigger than your whole area or you calculated something wrong somehow. Any questions on this one? Okay, now I need to go back for 1 second to this number 3. You are going to be tempted to use this hole puncher method on a problem that looks like number 3, but we have to be super careful because remember, the area of the shaded region is the area of the entire silhouette minus the hole punch. But I don't know how to find the area of this weird clover shape. We can't just call that weird clover shape 4 semicircles because it's not 4 semicircles. It's this weird clovery business. And then you're like, oh, well, I can just call this 4 full circles. And I'm like, no, that doesn't quite work because then you're going to have this weird part in the middle. I can draw that. You're going to get a weird shape in the middle that isn't quite covered. So this is a problem that cannot use that hole puncher method. You have to be very selective in what you're choosing because it doesn't always work. Okay. Questions on this first one, though? Any questions? Okay, let's do the last one. Same idea. I need the area of the whole silhouette. This is a silhouette that I know how to find. It's a circle. So the area of that whole thing, oh goodness, which is a circle. And we're going to hole punch a triangle. Area of the circle minus area of the triangle. For the area of the circle formula, I need pi r squared. I do not know the radius of that circle at the moment. So I'm going to take a look. Here's the center. And I'm going to draw in a radius. So from that center out to the outside, I'm drawing it in strategically here. That's my radius. Look familiar? Hopefully it does. I've got an equilateral triangle on the inside. This is a 30, 60, 90 triangle. That short leg is 8, so my hypotenuse is 16, aka the radius. And then the base of this is going to be 8 radical 3, if it lets me write. Okay, so put it all together. Area of the circle, pi, radius is 16 squared, minus area of that triangle. Now, I know that I have a formula for the area of a triangle. That's 1/2 base times height. However, I'm not given the height of this triangle, so I'm not going to try and find it. I'm going to use 1/2 apothem times perimeter. The apothem is 8, and the perimeter of this isn't too terrible. One side is 16 radical 3 times 3 is 48 radical 3. And again, I'm just going to plug that all into my calculator, get one nice big number, 471.7 inches squared. Any questions on that?